Section 7 deals with what we call, that word looks like arithmetic, but when we put it with sequences, we have to pronounce it a little bit differently. We pronounce it arithmetic sequences. So in this section, we're basically going to be looking at patterns, and we're going to extend those patterns. And these problems come up all the time on your MAP test and your ACT prep test and things like that. So it's important to be able to recognize patterns. We'll wind up representing arithmetic sequences using function notation as well. And we'll get into that pretty quickly. So I guess right after we come up with this vocab, we'll be diving into recognizing patterns. So let's first talk about a sequence. What is a sequence? In real life, a sequence is like a bunch of events that happen in a particular order. Like first you wake up, then you take a shower, then you eat your breakfast, then you go to school. Then you suffer through school. Then you go home and play video games, right? That's like your sequence of your normal day. So that's real life. Sequences in math are very similar. They are numbers, though, that are arranged in sequential order. Sequential meaning like numerical order or alphabetical order or event order, okay? So a sequence for us is just going to be numbers arranged in order. An arithmetic sequence happens when the difference, and we'll come up with a name for that pretty soon, the difference between each number is constant. Yes. But we're not there yet. That's like the next chapter. But yeah, that's exactly what we're saying. So if I gave you this as a sequence, 2, 4, 6, 8, that is an arithmetic sequence because the difference between 2 and 4 is 2. The difference between 4 and 6 is 2. The difference between 6 and 8 is 2. Okay? That's an arithmetic sequence. Common difference is the difference that I was just talking about. It's just the, so the difference between each number is the same. Okay, so an arithmetic sequence is an arithmetic sequence because it has a common difference. So an arithmetic sequence means that I have a common difference between the terms. And a common difference just means that I'm checking the difference between each of the terms. So those two definitions look very much the same. The term of a sequence is each individual number. In a sequence. So, in this sequence that I gave you, 2 is a term, 4 is a term, 6 is a term, 8 is a term. If you were to continue on with this pattern that we're seeing here, 10, 12, 14, 16, those are all terms as well. Each one of them is its own term. The first term would be the first one that you see, 2. To determine whether a sequence is an arithmetic sequence, it's a very straightforward process. You just got to remember how to do it. 1, check the common difference. If the difference is the same each time, then you have a common difference. And if you have a common difference, it's an arithmetic sequence. It's that straightforward. 2, if the sequence is arithmetic, then you can find the required number of terms. So it says, your directions will say, is it arithmetic, yes or no? If it is, find the next 3 terms. Okay? So, find the next 3 numbers in the sequence. Basically, I'm telling you just to find the next 3 numbers, whether it's arithmetic or not. So there is a pattern here. In this first one, what's the pattern? We're increasing by 1 each time. The difference here is 1. 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 Is this an arithmetic sequence? Yes. So write the next 3 numbers in the sequence. What are they? 6, 7, 8. Okay? This is how you're going to do these problems. You can draw little loops if you want to and say that the difference here is 1, 1, 1, 1. Because of the fact that the difference is the same each time, it is an arithmetic sequence. How about the next one, 1, 3, 5, 7? How much are we changing by here? 2. How about here? 2. How about here? 2. Is that an arithmetic sequence? Yes, it is. Now, tell me the next three terms. 9, 11, 13. We're just adding 2 each time. How about the next one? 6, 8, 10, 12. The difference here is 2, the difference here is 2, the difference here is 2. Is this an arithmetic sequence? Yes. What are the next three terms? 14, 16, 18. How about the next one? Now we're decreasing by 4. Or we could say that we're adding negative 4. How about from here to here, 29 to 25? Negative 4 again. How about from 25 to 21? Negative 4. How about from 21 to 17? Okay, so is this an arithmetic sequence? Yes, it is. What are the next three terms? Good. You've noticed that we're just changing by negative 4 each time. How about the next one? We're going up by 2. From here to here, we add 2. From here to here, we add 2. Here to here, add 2. Here to here, add 2. Is this an arithmetic sequence? Yes. So the next three terms would be? Okay. How about the next one? Is that an arithmetic sequence? Think so? Yes, we are adding an eighth each time. So my advice to you is this one looks weird because we have 1/2, 5/8, 3/4, 7/8. Looks weird. When you're dealing with fractions, you want to get a common denominator. So what I do on these is I rewrite these with the common denominator each time. What is my common denominator of halves, eighths, fourths, and eighths? 8. So everything's going to be divided by 8, and then I can make that comparison. So 1/2 turns into what? 4/8. 5/8 turns into 5/8. 3/4 turns into 6/8. And 7/8 turns into 7/8. Is this an arithmetic sequence? Yes, it is. Because we are adding 1/8 each time. 4/8 plus 1/8 is 5/8, plus 1/8 is 6/8, plus 1/8 is 7/8. So my next term would be what? 8/8, which is 1. My next term would be 9/8, which is 1 1/8. And my next term would be 10/8, which reduces down to 10/8 becomes 5/4. And if you wanted to make that a mixed number, 1 1/4. But remember, we stick with the improper fraction most of the time. So you have to make your common denominator first. Then you can see that it's an arithmetic sequence. We're adding 1/8 each time. And then from that, you can come up with the answer. Fractions ones are definitely a little bit more tricky. Those are the ones that you're typically going to see on your ACT test. So make sure you know how to do those. So this is just 3 more problems exactly the same as we've been doing, but the directions are a little bit different. This time we're asking you, is it an arithmetic sequence, yes or no? Then it says, if it is, then find the next 3 numbers. So it could be, or it might not be. Those last 6 that we were just doing, or 8, or however many it was, those were all arithmetic sequences already. Doesn't mean that there's not a pattern here. It just means that is it or is it not arithmetic. So how about this first one? Is that an arithmetic sequence? No? How would I know for sure? We got 6 here, we got 6 here, we got 7 here. So that is not an arithmetic sequence. So because it's not, we don't have to bother finding the next 3 numbers. We're done. How about the next one, this middle one here? Yeah? Yep, we add 5 here to get to -1. We add 5 here to get to 4, and then we add 5 here to get to 9. So we're going to say yes. We have to answer the question, it's yes. And then we have to find the next 3 numbers. The next 3 numbers are There you go. How about the last one? Is that an arithmetic sequence? How many of you think it's yes? How about no? Why? Why is it no? Are we adding the same amount each time? That's the key, okay? How much do we have to add to 1/3 to get to 1/4? Or subtract? Do you see a pattern here? Could I say the next three numbers? What would the next three numbers be? 1/7, 1/8, and 1/9. Yeah, exactly. Okay, you can all see that pattern. But just because there's a pattern doesn't mean it's an arithmetic sequence. In order to find out if this is an arithmetic sequence, what do we have to do? Common denominator. So what is the common denominator of 3, 4, 5, and 6 going to be? 60. Yep. So everything has to be divided by 60. It's not that bad. 3 times what gives me 60? 20. So this becomes 20 60ths. 4 times what gives me 60? How many minutes are there in an hour? What's 1/4 of 60 minutes? 15, see? How about 5 times what gives me 60? 12. So we have 12 here. And then 6 times what? 10. Now, are we changing the same amount each time? We change 5 60ths here, 3 60ths here, 2 60ths here. Okay? No. Does it mean there's not a pattern? No. There's still a pattern. It's just not an arithmetic sequence. Moving right along, we have 2 types of formulas that we're going to learn in this section. The recursive formula and the explicit formula. The recursive formula basically just describes what the pattern is that you're doing. The explicit formula allows you to come up with each sequential number in the sequence. These aren't that bad. You just have a weird word here, recursive. Kind of reminds me of spiders for some reason. Every time I see the word recursive, I think spiders, which is probably why I don't feel very comfortable with the word recursive. It has nothing to do with spiders, so don't feel uncomfortable. So a recursive formula is just a function rule, which we know what those are. They're basically equations that relates each term in a sequence to the term before it. So what do I have to do to get the next term each time? Basically is what you're asking yourself. And when you do that, then you write down your recursive formula. The recursive formula every single time is this guy right here. All you have to do is figure out what D is. D is the common difference. Yeah, you don't have to hate it though. Don't highly dislike it either. What you mean to say is that you didn't quite understand it fully, and this time you're going to definitely understand it. Hate is a pretty strong word, yeah. So I'm going to show you how to understand this, okay? It's really not difficult. The recursive formula every single time is A of n equals A of n minus 1 plus whatever the common difference is. This right here is the only thing that's going to be different in an arithmetic sequence. That's why we don't lean back on chairs. A of n equals A of n minus 1. What this means is my term that I'm looking at right now is equal to the value of the term before it. If I'm on term number 4, then this is term number 4 minus 1, which is 3. So whatever this is the term before the one that I'm looking at. And I'm just going to add the common difference to it to get that 4th term. That's all it is. So remember, D is the common difference in the sequence. That's all D is. So all you have to do is plug the common difference in and you're done. Here's why. If n is the term number in the sequence, then A of n is the value of the nth term in the sequence. This is very formal notation right there, nth term. If the value of term 1, then I'd have A of 1 equals 7. Then the value of term 2, A of 2, equals A of 1 2 minus 1 is 1, plus 4, which is the common difference, then I get 11. Then the value of term 3, a of 3, is equal to a of 2, which was 11, plus 4, which is 15. Then a of 4 is equal to a of 3, which was 15, plus 4, which is 19. So then a of n would be the term before it, a of n minus 1 plus 4. The recursive formula for the arithmetic sequence is a of n equals a of n minus 1 plus 4. And then they're telling you a of 1 is equal to 7. So the value of the first term is actually 7. There's nothing more to do there. So, bunch of practice problems. Write a recursive formula for the sequence below. What is the 8th term in the sequence? Well, we're going to write a of n equals a of n minus 1 plus, what's d? The common difference. And what's the common difference here? 7. That's the recursive formula right there. There's nothing more to it. Now it says, what's the 8th term in the sequence? How many terms do we have already? 4. So what's the 5th term? 91 plus 7, which is 98. Then 98 plus 7, which is 105. Then 105 plus 7, which is 112. How many terms do I have now? There's 4 here, 5, 6, 7. I got to find the 8th term, though, so I need to do 112 plus 7, which is 119. Okay, how about the next one? 3, 9, 15, 21. Write a recursive formula. Is there a common difference here? We're adding 6 each time. So my recursive formula is going to be a of n equals a of n minus 1, that's always the same, then plus the common difference, which is 6. That's it. That's the formula. Now we've got to come up with the 8th term. We have 4 already, so we're going to have 21 plus 6 is 27. 27 plus 6 is 33. 33 plus 6 is 39. 39 plus 6 is 45. Do I have to keep going?
No.
Nope. Done. How about the next one? 23, 35, 47, 59. Is that an arithmetic sequence? We're increasing by 12 each time. That's right. So I'm going to write plus 12. That's it. Now come up with the next 4 terms so that we have the 8th term. 59 plus 12 is 71. 71 plus 12 is 83. 83 plus 12 is 95. And then finally, 107 is the answer. Next one, is that an arithmetic sequence? Decreasing by 9 each time. So we're changing here, -9, -9, -9. That is arithmetic. So I can write the recursive formula. What is it? -9. Okay, come up with the 8th term. What will the 5th term be? 61, and then 52, and then 43, and then 34. Is that the 8th term? There you go. What does this right here mean? The term we're looking at is equal to the term before it. This is the term we're looking at. This is the term before it, okay? If this is the fifth term, then this would be 5 minus 1, which is 4. So the fourth term, minus 9, is the fifth term. The eighth term would be the seventh term, because 8 minus 1 is 7, which was 43. So we have 43 minus 9, which is 34. Okay? It's just notation. This is a name. This is a name. Don't get confused by it. Next one. Is this an arithmetic sequence? Yes? How much are we changing by each time? We're adding 0.5. So my formula is going to be plus 0.5. And now we need the eighth term. We have the fourth term. What's the fifth term? Okay? Okay? That's the eighth term. All right, the last one. Here's the fractions again. What do we do with fractions? We've got to have the common denominator first so we can see if it's a arithmetic sequence or not. Okay? So common denominator here is going to be 6. So I turn everything into sixths. And then there's 4 terms already, so I put in 4 terms, all divided by 6. The first one becomes 3/6. 1/2 turns into 3/6. How about 1/3? That turns into 2/6, and then 1/6, and then 0/6. So is this an arithmetic sequence? Yes. How much are we changing by each time? Negative 1/6. So I'm going to write my recursive formula is A of n equals A of n minus 1 minus 1/6. There's your formula. Still got to come up with the eighth term, though. So let's do this. It shouldn't be too tough. What's the next term? The fifth term would be negative 1/6. Then the next term would be negative 2/6. There's no need to reduce here because that's not my answer. Negative 2/6, and then negative 3/6. That's how many terms? I need one more, so we get negative 4/6, which is negative 2/3. So that'll be my answer.